Let's discuss the types and terms connected with chemical reactions. First, let's review the types of chemical reactions. There are three chemical reaction types plus simple decomposition. First, sulfuric acid reacting with sodium hydroxide to form sodium sulfate of salt and water is an acid-base reaction. Magnesium reacting with hydrochloric acid to form magnesium chloride and hydrogen gas is an oxidation-reduction or redox reaction because the magnesium changes its oxidation state from simple zero charge element to a +2 ion. And precipitation is given by an example of the reaction between potassium iodide solution and sodium nitrate to form lead iodide precipitate. In the magnesium hydrochloric acid and other redox reactions, it's electrons that are moving, in this case from the magnesium to the hydrogen ions. In acid-base and precipitation reactions, ions are moving or swapping places. Many textbooks call this following reaction a composition reaction. Different textbooks use different terms. Composition is also called synthesis, and in that two or more substances are combining to form a new compound. So substance A reacts with substance X to form compound AX. For example, copper will react with sulfur to form copper 2 sulfide. You can see the reaction here. What's another way to look at this reaction? You can discuss this and turn the video back on. Well, oxidation reduction is happening because the element copper appears on one side, the left side, as an element, and on the other side it appears as part of a compound with a +2 charge. The sulfur, which is an element here, appears as the sulfide on the right side or product side of the equation. And of course the physical characteristics of the copper and sulfur are much different from the copper sulfide. Therefore electrons are transferred. This is an oxidation reduction. Continuing our discussion of composition or synthesis, we have iron reacting with oxygen to form iron 2 oxide. Here is the equation. It's not balanced. Is this an oxidation reduction? Well, applying the criteria we just said, yes, it is. Another example of composition is the hydration of an oxide. For example, calcium oxide reacts with water to form calcium hydroxide. Calcium oxide is also called lime or quicklime. When you add it to water, you get heat. It's an exothermic reaction, and when it's called a slaking because you're adding water to it, it produces slaked lime, calcium hydroxide, and this is the crucial step for the setting of Portland cement. Is the slaking of lime an oxidation reduction? Look carefully and answer. It is not. Calcium is a +2 on the left and a +2 on the right, and that means there is no electron transfer. Let's talk about decomposition. In decomposition, a single compound undergoes a reaction that produces two or more substances. AX breaks up into A plus X. Energy of some kind is always required to break the compound up. So water decomposes by electrolysis into hydrogen and oxygen gases. If heat energy is used to decompose the substance, we call the process pyrolysis. If electricity is used, as it would be here, we call it electrolysis. This is also what kind of reaction? Look carefully and answer. It is an oxidation reduction because we have the elements on one side and a compound of the elements on the other. Continuing our discussion of decomposition, mercury 2 oxide decomposes to produce two elements. This was what Lavoisier did to produce oxygen. The mercury 2 oxide on the left, the mercury and the oxygen on the right. Is this an oxidation reduction? Well, yes. And carbonic acid decomposes to produce this, carbon dioxide and water. Is this an oxidation reduction? Well, the answer is the mercury 2 oxide is a compound producing 2 elements, and therefore it's an oxidation reduction. The carbonic acid, nothing is changing its oxidation state here. Oxygen is still -2 on both sides. Hydrogen is still in a compound, and therefore it's a simple decomposition. Other examples you will see probably in the lab are the decomposition of hydrates into an anhydrous salt and water. Now, metal carbonates decompose, and they break down as the carbonic acid did to produce a metal oxide and carbon dioxide gas. So, calcium carbonate decomposes to produce calcium oxide and carbon dioxide. Here is your equation. Is it an oxidation reduction? No, it's a simple decomposition. Metal chlorates decompose. When they are heated, they decompose to produce a metal chloride and oxygen. Potassium chlorate decomposes in this fashion. KClO3 gives you 2 KCl and 3 oxygens. This is a balanced equation. KCl is then used in a variety of settings, usually as plant fertilizer. This is an oxidation reduction. I hope you can figure out why we say that. Now for ion swaps. Anything that isn't an oxidation reduction or a simple decomp is probably an ion swap. They're sometimes called double replacement. Here's what it looks like. Compound AB in water reacts with compounds CD in water. These are ionic compounds, so they break up. And then you get AD and CB forming. The positive ion of the first compound combines with the negative ion of the second compound, and the positive ion of the second compound is found to combine with the negative ion of the first. The ions are swapping or trading places with each other. Instead of B here, you see D in the compound in the product. Now, 2 of our research and AP students actually published a discussion in 2015 arguing whether to say ion swap or double replacement, and I came down on the side of ion swap. The first kind is called precipitation. One of the swaps produces a salt or a base that has low solubility in water. You remember you mixed lead nitrate with, I think, sodium or potassium iodide, and you had 4 ions, 2 positive and 2 negative, the lead and the nitrate, the sodium and the iodide, all in aqueous solution, and they made a compound that can't be broken up by the water molecule, and the compound is lead iodide, and the water couldn't break it up, so it fell to the bottom of the tube. Do you remember the color? There's a picture. Acid-base reactions are also ion swaps. One of the swaps produces water. Water molecules hold together. You recall mixing hydrochloric acid with sodium hydroxide, and this gave us 4 ions, 2 positive, 2 negative, hydrogen and chloride and sodium and hydroxide ions. And when the hydrogen collided with the hydroxide, they made a compound that did not break up, water. And the word neutralization is also given to this ion swap. Now it's time to practice. You should be able to find a worksheet, chemical reactions, either in hard copy or on a website, and it's time to complete that reaction.